Welcome once again. I'm Charlie Greenberg, your host and moderator for webMethods Wednesdays, Software AG's weekly presentation of cutting-edge use cases and demos supported through webMethods technology, including integration, API management, master data management, BPM or business process management, and mobile technology, among other products, all of which play a solution-oriented role in the digital business platform. Software AG's innovative architecture enabling the rapid development of next-generation digital applications. Today, we'll be discussing the role of streaming analytics, the different ways streaming analytics are generated through business processes, and their value for decision support and predictive analysis. Our focus will be on the Apama solution, and our presenters are Jay Gauthier, Vice President of Integration and Product Management, and Jeremy Hills, Director of Product Strategy and Marketing. At the conclusion of today's presentation, we will be conducting Q&A, so at any point, please use the WebEx Q&A box at the bottom right-hand side of your screen for any questions or comments. And with that, it is my pleasure to introduce Jeremy Hills.
Thank you, Charlie. So for those of you who are unfamiliar with Software AG, Software AG is used by more than 70% of the Global 1000, and we have over 2.5 million users and more than 2 million developers. Our customers come from all industries, and you can see some of them on the screen here. If you want to look at those in more detail, please feel free to visit our website or talk to us. We'll give you our details at the end of this call. So without any further delay, this webinar is aimed at showing primarily webMethods customers how they can further optimize their business processes using Apama Streaming Analytics. So I should probably start by explaining what Apama Streaming Analytics is. Apama Streaming Analytics is able to track and monitor all the data that flows throughout your organization, wherever it is coming from, and respond to the business events that the data contains in real time as they happen. What this means is that businesses can respond more quickly to customer needs, improving customer profitability and reducing the number of lost customers. They can improve the quality of their products by monitoring production and responding to potential quality issues before they become a problem, and reduce fraud by spotting unusual transactions the moment they happen. So let's take a step back and look at how this works. It's been said that running a business is very much like steering a ship. You have to navigate around icebergs and turbulent seas, and the larger the ship, the longer it takes to change direction. While the ship may have aids such as radar to help it navigate, businesses have come to rely on business intelligence and analytics to do the same. The difficulty is that in order to gain a competitive edge, businesses need to act with increasing agility, and that means responding to business events the moment they happen. If a passenger were to fall overboard, then we need to send a life raft to rescue them. Similarly, if a customer is likely to leave, wouldn't it be better if we could recognize this and do something about it before they do? If we capture them at this stage, we have a far better chance of retaining them than if they've already signed up with one of our competitors. If we look at the three different types of analytics that businesses have available to them, we can break them into three broad categories. The first is analyzing information about events that have happened, which is important because you need that information to decide which direction to take the business, and you can't improve what you can't measure. The second type of analysis, which is streaming analytics, is enabling organizations to respond to events that are happening now. That might be indications that a customer is unhappy and might leave. It could be an indication that a financial transaction is fraudulent or that there is a fault on the production line. The third type of analytics is a combination of predictive analytics with streaming analytics, and that combines past data with what is happening now to spot patterns in your data to predict what is likely to happen so that you can take an action before it does occur. I thought it might be useful to take a look at how one of the leading industry analysts, Forrester, described what streaming analytics is. In brief, they say it is software that can filter, aggregate, enrich, and analyze a high throughput of data from multiple disparate live sources to identify both simple and complex patterns, to provide applications for context to detect opportune situations, automate immediate actions, and dynamically adapt. So what this means is that streaming analytics can monitor data from wherever it comes from as it happens in real time. It is able to enrich that information, so it can take information like customer number and add additional information like their gender and their age or where in the country they live. Streaming analytics can then filter on just the bits of the information that are relevant to it at any given point in time and make calculations based on that data, like rolling averages or sums or distance from a point. It is then able to spot patterns within that information and use that to trigger another event to automate a response. If we think about it, this is the key. If we want to respond to positive or adverse events in the business, there may be a lot of them. We not only need to spot an event, we need to automatically trigger another event or process to deal with it effectively. While talking about Forrester, I thought it might be interesting to look at how they view the streaming analytics market and where Apama streaming analytics from Software AG fits into it. Every year, Forrester publish their findings on the streaming analytics market and the vendors within it. In the Forrester Wave report on streaming analytics, they also chart the vendors according to the strength of their current offering on the vertical axis, along with the strategic direction it is taking on the horizontal axis. If you want to read a copy of this report, you're able to download a copy from the homepage of our website. Suffice to say, as you can see, Forrester have ranked Apama towards the very top right of the chart, showing us both in leaders in terms of our current product and our plans for the future direction of the product. Forrester have also explained why they believe streaming analytics is such an important technology, and they described data as perishable, and I think that is very true. We know that data has value. However, we often overlook the point that the value of data diminishes over time. If I want to prevent a customer from leaving, I need to do something about it before they leave. If I want to prevent a fraudulent transaction, I need to do something about it before I allow the transaction to go through. This means that data has its greatest value during the period of time you have to act on that data and do something about it. Once you've summarized the information in a data warehouse or a data lake, you can only view how many customers have been lost or how much money was lost to fraud, but it's generally too late to do anything about it. But what if you could spot these events as they happen and do something about it? This is what streaming analytics does. So what are the practical applications of this? Picking 2 or 3 examples, in the predictive maintenance field, it means that you can, for example, monitor the vibration of motors on a production line and pick up on a set of unusual readings that indicate that the bearings on a motor are about to fail. This means that you can replace the motor before it fails during scheduled downtime rather than waiting until it fails and causing an unplanned shutdown. Obviously, an unplanned shutdown generally costs an order of magnitude more than a planned shutdown. Schrager and Hasser in Germany use Apama streaming analytics to measure various information like the thickness of the copper cable they produce, which means they can fine-tune production of the cable continuously, which leads to a higher quality product. Water companies are able to use streaming analytics to measure the amount of water flowing in and out of the pipes. This not only allows them to adjust water pressure in real time according to demand, but they're able to watch for discrepancies in the amount of water flowing that would indicate a leak, along with which section of the pipework the leak is. Car engines are able to monitor how a car is driven to calculate the expected lifetime of the oil. This increases customer satisfaction that they do not have to bring the car earlier than necessary to have it serviced. By the same token, it extends the life of the engine as the oil isn't being used past its useful protected life. Streaming analytics applies across the entire organization, from customer analytics to risk management. It allows companies to make relevant offers to customers in real time while they're still perhaps on the website, rather than after they've gone elsewhere. Operational analytics allows organizations to monitor remote devices, for example, machine-to-machine or IoT devices in power-generating windmills, and respond to changing conditions or faults. So before we move on to a demonstration of technology with Jay, I wanted to describe briefly how this all fits together. The Apama runtime you can see in the blue in the middle of the slide is the part that captures your information as it flows from one system to another in the business. This information could be coming from webMethods, it could be from another operational system, or it could be from an IoT sensor. It can also pull relevant data from your existing corporate databases, for example, to look up customers' details. As it captures the relevant information, it's continuously performing the relative and necessary calculations to work out things like moving averages or total numbers. It is also watching out for specific events or combination of specific events which, if triggered, will trigger another event within an external system. And all of this happens in not much more than a millisecond. On the top left, you will see the rules that you are watching out for can be entered either through a business analyst-friendly graphical user interface, or it can be scripted using the Apama EPL language, and we'll see some of this in action during the demonstration. Those rules might be defined by someone in the organization, or alternatively, they can come from a predictive analytics model that has been built in products such as SAS, SPSS, or 9. The clever bit here is that Apama can learn from the actions it has taken by building the results or outcome of any action it takes back into the predictive model. So let me hand over to Jay, who will take you through the demonstration.
Okay, thanks, Jeremy. In today's demonstration, you'll see a live production application of some of the capabilities of the digital business platform, and specifically webMethods integration combined with streaming analytics. Now, I've called this application the Internet of My Things because I'm taking live data from my Fitbit wristband using webMethods integration server, and I'm sending live heart rate data and the number of steps taken to Apama, and where it's going to do what it does best: event correlation, aggregation, and pattern matching. I'm also collecting live data from my car using a device that I'll talk about in a minute. It's also using integration server, sending events representing trips that the car takes and unsafe driving alerts. It's sending all those events to Apama as well for the same kind of event processing. And I'm combining different event feeds, and that includes tweets. I set up a special Twitter account, and I'm sending Twitter information as well into Apama. I'll be showing the quick tour of the raw data that's collected from these devices, and then I'm going to drill down into two use cases that you should be able to see the similarity between what Jeremy was talking about with predictive maintenance and some of the other use cases as well. And this time I'm going to be using it with two alerts based on events that are coming in. In the first case, I'm calling it a tweet and drive alert. I'm combining two event feeds. One is the tweets that are coming from my phone and the car location events coming from my car. I'm watching for a pattern where the driver associated with that car is tweeting at the same time that they're driving, and I want to detect that as an alert. And you can imagine a concerned parent with a teenage driver, that kind of use case. In the second, I switch over to the Fitbit device, and I'm combining two independent feeds that come from the Fitbit, the heart rate per minute, and the steps taken. And in this use case, I'm going to be aggregating the data over time and watching for an unexpected rise in the resting heart rate, where I've defined that to be 30% above the average, the recent average, for a 4-minute period. And you can imagine a person with a heart condition. Now, knock on wood, as far as I know, I do not have a heart condition. I just imagined this, this use case, and I'm showing it with live data. Okay. Just, I mentioned this device in my car. This is a picture of my car. It's a Prius, and this is my license plate. This is a picture of the device. It's called Zuby, and it's a tiny device that goes into the port underneath the dashboard of most cars manufactured in the last 10 years. You plug it in, and it starts emitting events whenever the car moves. I saw this in an advertisement, and I recalled that some of our customers are doing connected car use cases for insurance or other cases like that. And I thought, hey, I should just buy this device myself, plug it into my car, and then I can stream that data into the digital business platform and make some demos around that. So that's what you're seeing today. This is a picture of my phone, and I'm also showing this Twitter account that I set up specifically for this use case to be able to send tweets. And I did this a few weeks ago. I just started sending gibberish on this Twitter account, and somehow somebody saw that, and I had a follower. The person said, "Awesome tweets." I don't know how they found out, but I have one follower on this demo account. Okay, the way events are flowing through these the different Software AG products, we've got the device that sends information through the Verizon wireless network to a cloud. Let's call it the Zuby infrastructure in the cloud. This data gets channeled into integration server using regular HTTP calls. The events then flow into Apama, where it's correlated with events coming from my phone sending tweets that get to the Twitter cloud, and that also gets into Apama through a Twitter adapter. Apama looks at all this and uses the rules that I define to watch for these patterns of a tweet and drive alert, and then when it sees that, it raises an alert. It sends that to the integration server, where we can do anything that the integration server can do with webMethods. It can kick off a process. It can save the data into a database or into Terracotta or anything it wants to do. And in this case, when I've programmed it to send me a text message whenever it's detected that the person driving that car is tweeting while driving. So imagine I'm the parent, gets a text saying somebody driving that car was tweeting while driving. So that's how I've set that up. And let me cut over to the live dashboard. And the first screen that I'm showing here is these tweets. And I've got my phone set up. And while we're talking right now, I'm going to send a tweet. And it should show up right away. Yes, I say, I just pressed the button, and it showed, "Hello, webMethods enthusiasts." It's got the latitude and longitude because I told it when I sent the tweet. I said, use my exact location. And this was received by Apama and just sent as an event so that it's picked up by this dashboard. Okay. What I also want to show is the trips taken in my car. And as I said, this device is plugged in. Whenever I start driving my car, I get an event that's sent, that's received by integration server. It says, "You've started a trip." Whenever I stop and I turn off the car, I get another event that says, "You've ended a trip." And in between, I've programmed the integration server to call out to the cloud to say, "Where is my car right now?" Every 2 minutes or so, it asks the Zuby cloud instance, "Where's my car?" using my ID, and it tells me it's at this GPS location. It tells me lots of other things. It tells me what location it is, what speed it's going, is it moving or is it stopped? It says the mileage and all sorts of things. This device also tracks unsafe driving behavior or possibly unsafe driving behavior, and that includes rapid acceleration and quick stopping. So for every trip, it gives a little report. And the trip this morning, you can see I had a pretty good commute this morning. Oops, I logged out while we were on the other presentation, so I have to log back in. Sorry about that. Oh, I'll show that other one later. Every time I log back in, I have to zoom in on the map again. You see that live. Okay. So this morning on the commute in, I had 0 rapid acceleration, 0 brake alerts, which means you have to stop quickly. And when you get one of those alerts, it tells you how fast were you decelerating at the time, what was the speed you were going. And the same thing with the rapid alert for acceleration. It says it's trying to highlight conditions where you're driving and you're going maybe in and out of traffic, going fast, passing people and doing all that. So I drive a Prius, and as you can see, I've got 0 rapid alerts. I think I have 1 in all of this one day a few weeks ago. But it could have been my wife driving my car at that time. I'm not exactly sure how that happened, because I've tried getting a rapid alert in my car, and I would get onto a highway and push on the gas and go as fast as I can, and still I wouldn't get a rapid alert. But I get these brake alerts all the time. This view, so when I click on one of these trips, it shows the points in between. It shows the start event of what time it started. This morning I started my commute at 7:50, and I ended at 8:30. That's when I got to the office, and this is showing the map where I live in South Riding, south of Dulles Airport, and where I work is in Reston. And I've got a history of all the different trips. This is just showing the dashboard of what the device is collecting. I'm now going to go over to the alerts that were raised, and again, I have to zoom in on the map here, so just bear with me. Okay, so this is showing all the alerts that were raised from this car in the last couple of weeks, and you can see that there's a lot of hard brakes, and these are actually I changed the calibration about a week ago because I was getting so many hard brake events. I guess in stop and go traffic, it happens quite a bit. Someone pulls in front of you, slam on the brakes, and then all of a sudden I got a trigger. And I wanted to separate that kind of brake from something that's more severe. And so I was observing the acceleration thresholds, and I noticed that some of them are below 8 and some of them are more than 8, or I guess it's -8. And so I changed the rule that I used and said only show a hard brake alert from the device if it's bigger than a certain deceleration. And since then, I haven't got any. They still show up in my trip reports, but they don't show up in this dashboard because I basically filtered them out. And that's something that you'll see in a lot of real live cases when you have raw data. Some of it you have to calibrate over time. You're not exactly sure how to trigger these alerts and what should be treated as an alert. You might have to adjust some things. And I'll talk more on that in a minute. So in this case, there's 3 different types of alerts. I've mentioned the hard braking, I've mentioned the rapid alerts, and I want to zoom in on the tweet and drive alerts. So for this one, I'm going to go back to April 27th. If you notice that there's an alert that's on Highway 50, I'm going to go back, and this is referring to what Jeremy talked earlier about. There's present information that's flowing through the system, and there's past information. In this example, we're looking at some historical events, and we're drilling down into when that happened and where. So I'm going to go back to that exact time on April 27th, and I'm going to show that at that time I was coming back from a card game, and I was driving, and I knew that my system was running, and I wanted to test, is my event alert system working? So at a stoplight, I sent a text, and then I started driving again, and within a minute, I got a text on my phone saying, you were caught tweeting and driving. So that was this example, and I want to talk more about what this looks like in APAMA. So I'm going to switch to the rules that were used to detect this tweet and drive alert. And I'm going to look at this in a few different ways. So at the high level, we're looking for a car event plus a tweet plus a location. They have to be correlated where it's the same person, and that's so that if my application is monitoring 2 or 3 different cars with 2 or 3 different people with Twitter accounts, we have to associate the Twitter feeds with users that are driving those cars. The rule says those 2 events have to say that the car was moving and that the Twitter location of that tweet was with the GPS coordinates reasonably close to where the car was at that time. And all of that has to happen within 3 minutes. And what this looks like in Apama, I'm going to just pause on this screenshot right for a minute, and it's showing the actual user interface for this rule in the graphical user interface inside Apama Designer. And in the middle of the screen, it's a depiction of the 3 different events with the arrow saying the order, get a vehicle 1 event first, followed by a tweet, followed by a second one. There's where clauses that talk about the latitude and longitude have to be within a proximity. And you can see this proximity is a variable. So when I was calibrating this, I would try different percentages or different floating point numbers to see how close are we talking about. And the way I would test it is I would drive, and then I would send a tweet, and then drive again, and it might not recognize it. I might have been too far or too close, so I had to calibrate that, and I adjusted the rule that way. You can see within 3 minutes, this is one of the rules, and they're correlated by the vehicle ID. So what I did was I said this Twitter account is associated with the driver of this car, and so I'm using the vehicle ID to say when a tweet comes in from that account, I'm going to add on the data that says what car does that person usually drive, and that's how we're correlating these events. And whenever this pattern is detected, then we send a tweet and drive alert. So that's this in the middle on the right-hand side. So I was just showing the screenshot of the live data. This is a snapshot of that showing on this day, April 27th at 11 p.m., 11:19, then there was an event that said the car was moving. There was a tweet, and I tweeted, "Catch me if you can." And then I kept on driving. There was another car event that said, "Now you're in a different location." Both of those events said that the car was moving. The location was correct because on my screenshot from my tweet, it says you were in Chantilly, and that's really where I was. And it was all within 3 minutes because that's the screenshot shows within 11:22 and the same time as those 2 car location events. And here's a screenshot of the tweet that I got on that day at that time. And it even says what was the tweet that was that caused the alert to be raised and what was the user. So all that happened, and I got some screenshots there. Okay, now let's switch gears a little bit. And that's the end of one use case. And now I want to move on to the second use case about data coming from the Fitbit device. Now, in this case, I want to correlate 2 different event feeds. One is a set of events that say, what's my heart rate every minute, 24 hours a day, sending that as a stream into Apama, and a second set of events saying how many steps were taken during that 1 minute period, also as 2 separate events. In terms of the rule that I want to track is watch for an elevated heart rate above 30% for 4 minutes, and it's got to be unexpected. And the way to tell if it's resting heart rate is that there's 0 steps at that time. Okay, and in this case, this is a picture of the wristband that I have on my wrist. I've been using it for a couple of years. This is my phone, and the way that this synchronizes is there's a Fitbit app in the background running on my phone. It synchronizes about every 10 minutes. That data gets put up into the cloud, and then I've got an integration server that polls that Fitbit account. I've given it permission for this application to access my account and my data. So this application calls in approximately every 10 minutes. It gets the most recent data that it's been collecting, and it sends those events as streams into Apama, 2 separate streams, one for heart rate and one for steps. Apama does its magic, watches for these patterns, detects alerts, sends it back to the integration server, and the integration server can then act on that. Now, in all of this going on, as you can see, there's a dashboard that allows some visibility into this data that's flowing and the alerts that are happening. Okay, so now I'm going to cut over to the Fitbit data, and I'm looking at this clock, and it's saying that it's 10:32 my time, and at 10:36 there's another, I'm due for another automatic update, but I want to force an update. So what I'm doing now is going to my Fitbit device and saying, I want you to synchronize right now so that I know that there's some data. And then I'm going to do a forced refresh. Just a minute, and you can see the live streaming data. So right now, if I just kind of cause it to go, and I'm now getting the most recent data from 10 minutes ago, or however many minutes ago. Actually, it's from 3 minutes ago. So this is my adjusted heart rate. It's not my real heart rate because I want that to remain private. So I've adjusted the real heart rate, and what I'm really looking for now and what I'm demonstrating is that the heart rate changes over the day. It changes in some ways correlated to the steps that are taken. And let me show a little bit about that. If you notice, then I first received some steps right until 10:29. Sorry, the heart rate until 10:29, and then right after that, the steps feed started, and I got also steps until 10:29. So these are a little bit out of sync right now, so you can tell that on this side, the most recent data is 10:29, but at this time, on the left-hand side, it's 6:15 versus 6:37. That's because when I take off my Fitbit, I no longer get any heart rate data. But if I later ask what were the number of steps taken during that same period, it shows up as 0 steps. And so there's a bit of a disconnect in this data where sometimes you get no data representing some of the minutes in the day, and in the steps case, you get all of them represented, and so there's no gap there. So this is off by a little bit, and but it's still interesting to look at what happens when I'm walking or running. In this case, this morning I was doing some exercising, and it shows that I was doing a lot of steps every minute, and at the same time my heart rate was had risen. And then later I've gotten ready and I'm starting to drive into in my car, and at this time between 8 and 8:30 or so, I'm driving in, so I have 0 steps at that time. But my heart rate is higher than my normal resting heart rate adjusted, and I suppose that's because if I'm driving in traffic, then my heart rate is rising a little bit. I get into the office, I'm walking around a little bit, and it's just showing that when I'm at rest and not moving, then the heart rate kind of slows down. Whenever I start moving, then it rises. Okay, so this is a little bit about the live data, and I want to just mention what Apama is doing in the background. Apama is looking at both the heart rate and the steps, and looking for a two-hour window, saying for all of those minutes where you had 0 steps, let's compute the average resting heart rate. And the most recent average resting heart rate for the last 2 hours was 78. And this changes during the day because in some 2-hour periods, if I'm walking a lot, there's not a lot of minutes where I have 0 steps. And so there's not a lot of numbers in the average. Some other times, if I'm sitting at my desk for a few hours, then it's more average. And you can see in here that even though it's a 2-hour average of resting heart rate, it jumps between, in this case, these big swings, and that depends more on not what my actual resting heart rate is, but it's how much activity, what the sample size is. Okay, so I'm going to now go over to the alert, and at the beginning I mentioned that in addition to the 2-hour average, I'm also looking every 4-minute chunk in a moving window. I'm looking at every 4-minute window, counting the number of steps and the number of heartbeats, and I'm looking for a pattern of higher than 30% above average in the last 2 hours. And that's just a running query that's running all the time. And I have a little dashboard here showing these alerts. And I want to show one from yesterday. The most recent one that triggered this was yesterday, that there was a 4-minute average that was higher than the normal average. I do want to pause here to mention some of the ways that I calibrated this particular alert, because when there's raw data, I didn't know what to expect with the number of steps I took and my heart rate at different times of the day. And I wanted to make this rule of looking for this case because I was thinking about a use case. And I said, okay, how do I make my heart rate go higher for 4 minutes or 3 minutes? When I started this, I used 3 minutes. And I need to know I'm not doing any steps and I have to get my heart rate going. So the first thing I tried was going on the floor and doing some exercises. But I had to make sure that I wasn't moving my arms too much. So I did that, and I was constantly looking at my number of steps on my watch to make sure I'm not doing too much activity, but I had to do enough that my heart rate got up. So the first alerts like this were set at 20% over 3 minutes. And I was able to do that after my exercising. I got my heart rate up. I ran over to my computer, and sure enough, I had an alert here. Then through the rest of that day and days after that, I was getting these alerts all the time. There was many cases where for 3 minutes I was 20% above. So I had to calibrate it, and I first went from 20 to 30%, then I went from 3 minutes to 4 minutes. And every time I got it, I would look, because I'm not doing my exercises on the floor every time, I had to understand why was I getting those alerts. So I'd go back in the history and take a look at the number of steps and what time it was and all that, and I would verify that the average was correct and the heart rate was correct. So in this case, I did all that, and I noticed a pattern that if I was walking around, the heart rate was up, and then if I stop and sit down, then for the next 4 minutes, I might be 30% above. And so every time in the last few weeks I've been watching this, that's been the explanation, is that, and I still wanted to trigger it because I wanted to have something to demonstrate. I didn't want to rule that out, so I left these alerts in. And then yesterday, I had this alert, and I went to my Fitbit history, and with this dashboard, I'm allowed to look back. I can use this dashboard to go back today. Right now, it's showing today's data. I'm going to go back because the Fitbit cloud retains my information for I don't know how long, probably years, because it goes back as long as I've had a heart rate monitor, so it's more than a year. But I'm going to look at yesterday. So I'm going to take the data from yesterday, and I went back to that alert, and I said, what time of day was it that I got this alert? And I just sorting here. It was around noon. So I went to the Fitbit data, and I noticed this between 11 and 12, I was at 0 steps all the way through. But between 11 and 12, I had this spike for a few minutes here and a few minutes again. And this is the first time yesterday that I noticed I don't have an explanation for that, because I was walking before 11, and then my heart rate stabilized, and then I don't show any steps, and I have this elevated heart rate that I can't explain. And I didn't do this for this demo. I'm just telling you this is the live data that I observed yesterday. I'm not sure why it was that way. Maybe I was reading an email or doing an email and I got really agitated or something, but I can't explain this. And every other time I've been able to say the heart rate is that way because you were just moving. So this is a mystery to me, but at least I have the data that I can look at, and I can start tracking this to see how often this is happening, because, you know, I don't think I have a heart condition, but maybe I'm getting too animated when I do some emails, and maybe that's a lesson that I can learn. Okay, let's go back and take a look at what Apama is doing with all this data. So I mentioned there was heart rate data coming in that has the timestamp and the heart rate. There's also the steps data that also has the time and the number of steps taken. This is approximately 10-minute delayed. I'm doing a very common thing, which happens in Apama. You want to correlate two different event feeds and bring them into a new event. So I would take those two event streams and I would make a new set of events, one per minute, with the time and the heart rate at that time and the number of steps at that time. So that's a very common pattern to correlate data. I then passed it into an aggregator that said over the next 2 hours or every 2 hours, then count all of the heart and step events that had 0 steps for that period of time and count the rate and make it an average, a moving average over the 2-hour period. And every 2 hours, send out a new event that says this is the 2-hour average. At the same time, I'm sending another set of events that is the sum of the last 4 minutes, and it's taking the number of steps and the number of heartbeats over that 4-minute period. And finally, that's doing the aggregation, and finally it's the pattern detection, saying look for a recent average 2-hour rate, and at the same time there's a number of steps that is 0, and there's the number of beats over 4-minute period that are bigger than 130% of the resting average. And we saw that that actually triggered, and I was able to see that in the dashboard. And this is just a reminder of how the event feeds flow, and this is very common in many cases with webMethods and streaming analytics put together. Event feeds are coming into either the integration server or going directly into Apama. Events often flow into Apama for doing its event processing. Alerts can get sent not only to integration server, but to anybody that's listening. And then often there's a dashboard that goes over top of this to allow you to visualize this combination of events and alerts that is going on within your application. And at this point, I would like to turn back to Jeremy to go over some real customer use cases that are also related to streaming analytics and webMethods.
Thanks, Jay. Right. So I thought next it might be useful to have a look at perhaps 3 organizations that are benefiting from the use of Apama. The first one is General Electric. Now, General Electric continuously monitor 3,500 managed gas turbine engines. They found that by proactively identifying the maintenance issues, so this is a predictive analytics example, they've been able to save $4 billion a year in costs, as well as reducing the downtime and increasing reliability. And that's obviously had a benefit in terms of increasing customer satisfaction. So that's a definite win-win for them. The second example is Wiesmann. Wiesmann are a German manufacturer of what in the UK we call boilers, so heating systems. And I believe they're the leading manufacturer of such products. They've been able to use Apama to optimize the production line in such a way that has resulted in a 20% increase in their renewable energy use by instantly matching the power demand to the supply. And it's had an additional benefit of reducing their consumption at the same time, their power consumption. The third example I wanted to cover is a global pharmaceutical giant who have been able to streamline their supply chain process, especially with regard to reacting to events that happen in the last mile of delivery. And the result of this has been that the timeliness of their deliveries has improved worldwide, and as a result of that, the corresponding service level agreements penalties have been reduced by 25%. This also has an impact on customer satisfaction by being able to do something about an unforeseen event early on in the process. It allows them a greater opportunity to take corrective action and therefore get the delivery there on time and make their customers happier. So in conclusion, there is still a great deal of untapped value in the data in your organizations, And by acting on events while the data is still relevant, your organization can become more responsive, which in turn means you can increase your customer satisfaction, you've reduced downtime, while increasing quality and minimizing the risk of fraud. At this point, I want to hand over to Charles. Sorry, I forgot to mention, if you want to know more about Apama, please go and visit us at analytics.softwareag.com. And at this point, I'd like to hand back to Charlie. Thank you.
Thank you very much, Jeremy, and thank you, Jay. That was a very well done demo, and one comment or question, which I'll just relate to that right now, is there a way to have a trial of this product?
Okay, I'll field that first.
Okay.
Yeah, go ahead, Jeremy.
Yeah, I was just going to say, yes, you can. There will be, if you go to the Apama section on the website, you will see that there's a link there to download the trial version, and you fill in the form, and that will be sent over to you.
All right, thank you.
And a related question is that brings on Apama, and I'm not sure if there's one for Mastodon NextGen. I can't remember. I don't think it's in that same one for Apama, but there might be. I just don't know the answer to that question, so we have to get back on that part of it.
Okay, and we will get back to that. And if we don't answer all the questions before the end of the hour, I want to point out that both Jay and Jeremy's email information is at the bottom middle of the screen you're currently looking at, so please take note of that. We'd love to talk to you if questions occur to you after we've left the session today. Additionally, we're also joined, and we're going to do a real quick sound check, but we're also joined by Dr. Jürgen Kramer, who's the VP of Streaming Analytics as far as Software AG is concerned. Jürgen, can you speak? Can we hear you?
Yes, thank you. Can you hear me? So yes, thank you for the kind introduction.
You're very welcome. Thanks for joining us, and let's move to the Q&A. Firstly, regarding the demo again, do you have a use case of enriching the real-time events with static data in the demo?
Yeah. So when this is Jay, when I was showing the Twitter events matching with the car events, you might envision a world, and I think I mentioned at the time that and Jeremy mentioned it as well, you take the event coming in, and in this case I was taking the Twitter feed that has the Twitter account, but then I wanted to associate that with one of the vehicles. And so in a real application, there would be some way of correlating that, maybe a Facebook ID that's common to Zuby and also to Twitter, and then that would be in some kind of lookup table or some database or something, and you would enrich that at the time. And that's, I did it kind of hard-coded, but it was the same idea. So that's where that comes into play. Okay.
So we know we're seeing some products in addition to Apama in this demo. Was Terracotta in there?
Yes, I mentioned that at the, well, I did mention it in the slide, but I didn't mention it in the, while that was happening. And what you noticed and I didn't call it out, but when you were looking at the data in the dashboard, some of the data was live, and it was meant to be showing what is happening right now. Some of the data was meant to be historical. And for some of the historical data, if it already existed in the cloud, then I just left it there, and that's some of the information from Fitbit, for instance. But some of the data, like the alerts that had happened in the past or the trips and the trip points along the way, I wanted to preserve that. I didn't want to treat it as just an event that goes off to Apama and then it's forgotten. So I put all that into a Terracotta store, and I've got it set up so that it's the data stays in the Terracotta instance, even when it's shut down and comes up again, I make sure that there's a big enough space to allow that data to be stored. And then eventually, if I fill up that Terracotta cache, then I can purge it and start over again, or put the oldest ones away. So yes, Terracotta was in there. I just didn't call it out.
All right, and just one more question regarding the overall architecture. How does Integration Server connect to the cloud services?
Okay, this one was kind of interesting because I had to learn how I could get the Integration Server to connect to Fitbit and to the Zuby cloud. And I got the idea from seeing a demo at a different partner site that I was at, and I saw a Fitbit showing on a screen, and I said, how does that happen? And so I got the idea, and I didn't know that Fitbit had an API. So I started looking at the public Fitbit API, and they use something called OAuth, which is an authentication scheme that's used by Facebook and probably something like PayPal. And you may have seen it when you go to an application and they say you have to use your Facebook or some other Twitter account information, and then you go in and you give permission to an application to see some of your data. So that's what was done with Integration Server. It's calling out using a regular HTTP, but it's using OAuth authentication to get some tokens, and then it passes those tokens in the header to the cloud instance, and that makes sure that this application tied to my personal data that is owned by me, I gave myself permission for this application to read that data, and it's handled by these tokens in Integration Server doing regular HTTP calls. I did want to mention that all of the code that was implementing this was done with pretty basic Apama coding and pretty basic Integration Server. There's maybe none of the elements of this is more than 20 lines of code. So there's not an awful lot of custom code in there that implements all this. In this, because it's a relatively simple use case.
And how would you build the rules you want to use in Apama?
So there's two ways. I seem to be dominating all the answers here, but there's two ways to do this. One is using the EPL language within Apama. This is an event processing language that's proprietary to Apama, and it's a programming language that is designed for events, event filtering, event aggregation, etc. So you can code it that way. Or you can use a graphical user interface like I showed that is kind of a layer on top of the EPL code, and it's either one. The advantage to using the query, the graphical user interface, is that you can pass in parameters, like in this case that I showed, proximity was a parameter. And then while the system is running, you can tell the system for that rule, I want to change the parameter. I don't want it to be 50% right now because I've been looking at it and that's I want to calibrate it. At runtime, you can say, I want that rule to now be 60%. And it changes it immediately and it starts acting on those new rules.
Thank you. And
yes,
Jürgen, let me direct this one to you, and feel free to add additional commentary, but how does Apama capture the events in its monitoring?
So let me just add something to Jay's question. So the tooling of Apama queries also has a round trip. So you can start with the graphical thing with the boxes and arrows and so on. But you can also then switch to the more developer perspective where you see the EPL code. So now to your question, what do you exactly mean with the monitoring? Is it really how we capture the events coming from the data sources, or is it about the monitoring capabilities in Apama?
Well, that's a question, so maybe you should do both sides that you just mentioned.
So, okay, to ingest data into Apama, we have different frameworks. We have the so-called IAF, Integrated Adapter Framework, that provides a very rich set of out-of-the-box adapters for files and for lots of adapters, for example, in financial markets and so on. You can also build your own adapters. but these are running as a separate process and then sending data into the Apama correlator. And we have something new in the latest release, which is called Apama Connectivity Plugins. It's again a framework with plugins for transport and codecs, so how you convert external events, for example, from a JSON format then into the Apama internal format. This is done for you, but you can also create your own codecs. And the beauty of these Apama connectivity plugins is that they are running in process. That means really inside of the correlator, not as a separate process. And then for monitoring, Apama provides its own sophisticated monitoring capabilities to monitor the memory usage, CPU utilization, and so on, and also the adapters. But we're also plugged into Command Central if you have a more holistic webMethods-based approach.
Thank you very much. I want to thank again, on behalf of webMethods Wednesdays, Jay Gauthier, Jeremy Hill, and Dr. Kramer, Dr. Jürgen Kramer, for joining us in the Q&A. If you are interested in a free trial of Apama, please contact us. We have a link we can send you. In the meantime, please note the ongoing webMethods Wednesdays schedule, which is fairly robust up until July 4th, when we'll take a week off for the holiday, at least in the United States. In the meantime, thanks for attending, and we look forward to seeing you again.